Okay, so let's keep talking about the use of VR AR. So we talk about the use of VR for the design and also for the construction. So let's talk about the maintenance and operation. Like I mentioned earlier, AR is becoming a more popular technology for operational support because we do have the need to see the real world. I'm just going to show you two quick examples from Bentley that they are really advancing. um, they're pioneering the use of AR in this operational support.
When you have located the affected system, say, acknowledge alarm.
The AR has this eye tracker. What you see here is basically showing the gaze focus of the user.
Acknowledge alarm.
To leave alarm mode, say, clear alarm.
Okay, something's wrong here. What's the problem? Display PNID. Well, we have a heat exchanger here. Okay. Describe alarm.
Pressure at instrument PIT 5003 is below 2 psi threshold. Current pressure is 1.5 psi.
Okay, PIT 5003, that's the one. Locate item. Where is it? Okay, that's the one. Yeah, the pressure is very low. Are there some readings for this? Display readings history. Move. Okay. There was a maintenance on Wednesday, July 13th. Oh, there was also here and here. And just before that, the pressure was very low. And after that, the pressure gets back to normal. But there are some very high peaks of pressure. And after the peaks, the pressure seems to decrease. That's weird. Hide. Well, are there some video reports for those maintenance? Display maintenance history.
There is a video clip for the third entry.
Move. Okay, there's a video.
Now, what you see here is not just a video, it's actually a 3D record of this person. So the HoloLens also has this depth camera. The depth camera can create a point cloud model of a person, so which is pretty much a 3D hologram of the person. Oops.
Maintenance pressure. Display maintenance history.
Hi, I'm Ben O'Connor. Okay, hi, I'm Ben O'Connor, and it's October 23rd, 2016 in the afternoon. Actually, it's 1:18 p.m. Today, the pressure indicating transmitter 5003 stopped working properly. Measured pressure was way too low, so I replaced it. But we did the same thing last month and back in July, so that means we replaced it 3 times in 4 months. That's way too much for these type of device because they usually last more than a year. It indicates there's probably something is wrong with the system, but we would need further investigation to confirm that. See my report for additional details.
Okay. Hide. So the problem keeps repeating. We'll have to do something about it. Clear alarm. Okay, since this is a heat exchanger, the instrument indicates the differential pressure between this pipe and this pipe. And why the instrument is broken may be because the differential pressure gets too high between those two pipes. So a solution to this could be to add a bypass between those two pipes. Well, let's do that. Okay. Those are the pipes in question. Okay, add bypass.
When you have found a suitable configuration, say, accept bypass to save your design.
Okay, I need to find a good configuration. Okay, this is the bypass, but right now
And once again, it shows that a design in this schematic drawing is quite different from this real world and real world configuration. And this one shows that how AR can help you project the 2D design into the 3D world and find out the best configuration.
it is red, indicating that it's colliding with this pipe. Move. If I move it here, well, that's not better, since it is occluding the instrument. Move. If I pull it here, well, this is in the way. If I push it here, I think this could be good. Yeah, that's interesting. Okay, I think it will be that. Accept bypass.
Your design has been saved. Returning to free mode.
Okay, so we have to plan a maintenance for the modifications, and the problem should be solved.
All right, so the next video shows that how they use the same AR system to replace the valve. It's pretty much the same thing. I'm just going to show you some screenshots, like it show the sequence of doing the replacement and also use the arrows and some animation to show the worker how you should replace that, how you should rotate that. This is actually how AR can be used for operational support. All right, so I talk about this VR, AR applications, probably the most representative applications. Now let's look deeper into VR, AR. Like I said earlier, I believe the evolution of our industry is actually the information evolution. So we have been moving from 2D drawing to 3D models, all the way to this immersive VR, AR models nowadays. And also we are, by adding the semantic information into the model, we are getting rid of the textual information somehow. So the question is, here's the biggest question for you guys. Is VR and 3D better than the traditional information format? Can anybody tell me your thoughts? Is VR 3D, those immersive methods are always better than the traditional methods such as 2D drawing? Yes or no?
I believe it's much better than 2D drawing, like in the way that we understand the visual information.
Okay. Anybody else? So I assume most of you believe VR are better, right? Okay, so here's the thing. Conflicting findings. People start to look into these emergency information methods and see how and view these methods benefit construction operations. Unfortunately, we have very different and conflicting observations. Some researchers say, yes, 3D and VR models can definitely benefit the construction, but somebody discovered, different data, different evidence. They say, actually, they didn't observe improved performance giving 3D models and VR compared to 2D drawings, or sometimes they see the negative impacts. And interestingly enough, guys, both, group of people gave the same explanation. For those who say VR 3D will benefit, they say because they provide additional information. But for those who observe the negative impacts of VR and 3D, they say, oh, because they provide additional information. So you have to process additional information. So after we perform the literature review, we notice that the story is not that simple. We cannot simply say, yeah, because of VR and AR and all the new technologies, such as building information modeling, emerging, it means the better methods, it means improvement. No, never happen that. Just give you a quick example. For example, if you have been always trained with AutoCAD and you are so into reading the 2D drawing, I give you a 3D model or even VR, you are probably confused, right? So it's more than that. And we need a better way to identify why VR and 3D can benefit certain people, certain group of people, but while to the other group of people, they even reduce the performance. We need to better understand what happened. Make sense? That's research. Okay. Research is not about I make observation. I observe, yeah, my research is about how can VR improve performance. Now I have my conclusion. No, that's not research. Research is go deeper, try to find a reason, try to find out why. And this is how we do that. We want to measure your brain. So we know this must be driven by what's happening inside the brain. So we want to understand when I give you this 2D drawing, when I give you the 3D model in the VR, what happens inside the brain, or cognitive process. And this is my research focus, okay? So we use something called neuroimaging. What you see here, that's called FNIRS. I don't know if I have a picture of FNIRS later. No, okay. So FNIRS is actually, you see all the red dots here, the red props here. It sends infrared light into your brain, about 2 to 3 centimeters deep. And all the blue dots are reading how much infrared lights are absorbed in your brain. Because oxygen and carbon dioxide absorb the infrared lights in different degree, actually different, frequency of infrared lights. Like oxygen likes certain frequency and carbon dioxide likes other certain frequency. So we can check, we can convert that number into the oxygen level in your area. So basically, if you see here, it sends out the infrared light about 7 to 8 times a second. Now this one reads the level change. Now we know in this area what's the oxygen change, and we know different areas of the brain represent different functions. Let me show this quickly. I have this brain model. You guys can see this brain model here. So this is the front of your brain. This is the back of your brain. So we know the front of your brain here, that's called a prefrontal cortex, or PFC. It's responsible for like a logic thinking, planning, activity planning, and also working memory. We also have, these two areas. I don't know, you can see like these areas is responsible for language processing. This area is called a motor cortex. It's for you to coordinate your motion, your hand, everything. The back of your brain, interestingly enough, is responsible for visual. Your eyeballs are here, but the signals are actually sent all the way to the back to process the visual information. And the spatial information processing is inside your brain. The hippocampus area is responsible for spatial memory and spatial processing. So then this infrared light will send into about 2 to 3 centimeters into your brain, so we can check the oxygen level. Now we can map how your brain thinks. And that's one method, but also we use pupillary dilation. When a person gets nervous or thinking too much, your pupil size will enlarge, okay? And also you tend to blink more. You feel nervous, like if you're lying to a partner, you tend to blink more. You cannot hide that unless you're well trained, okay? And also ECG, this measures the heartbeat. It's not just the heartbeat number, but also the electrical signature of your heartbeat. So from there, we can also tell if a person is nervous or if overloaded by something. So in general, we want to understand when I give you a 2D drawing, VR model, 3D model, what's inside your brain, your burden in your brain. And this is the eye tracker embedded in VR goggle. As you can see, those are infrared lights. So again, we are using infrared lights so we can check the size of and also the gaze focus. This is the real-time image of how the machine learning model is picturing the boundary of the pupil, and you can see the pupil is changing very fast. We're talking about a millisecond change, okay? And the center shows the gaze focus. It shows where you were looking at. And like I said, the pupillary dilation is a strong indicator of your cognitive load, but it can also be easily affected by the light, right? So if it's brighter, your pupil will definitely shrink. So we actually developed an innovative way to remove the light response based on pixel. You know, each pixel is actually the RGB value, and we do have a formula showing that how your pupil will react to the red color, blue color, and the green color. So we actually have this computer program we coded ourselves that can calculate the RGB value of each pixel on inside the VR goggle, convert that into the brightness, and then remove that from the light response of your pupil exchange. It's not that simple. One thing is called the latency. Like for example, if I point a very bright light into your eyeball, your pupil will shrink, but there's a delay. And that delay is different across people. If you are drinking too much alcohol, the delay time will also change. So we also need to find out, the delay time from data. So we actually performed a lot of mathematical method here, and finally we removed the light response from your pupil change. And so we basically measure, like your gaze focus, we check your body motion, we check your eyeball, we check your pupillary dilation, and this one shows the gaze focus. We also want to see how frequently you're moving your focus. This is something called attention split. Like if you're moving too much, it probably means you are having too much information to digest, so you have to move too frequent. As you will see quickly here, the playback. Yeah, actually, this is very interesting research. I don't know if you guys can tell. We actually did a lot of work ourselves. Like what you see in a moment in this video, like the eye tracker is built here. That's the eye tracker. Again, infrared lights to track how you rotate the eyeball and translate that into where you're looking at. But it's very difficult to track a beam model, because beam model is 3D model. We can definitely track which pixel you're looking at, but how can we track which area in this 3D model you're looking at? So we actually develop that's once again our own function. It's kind of like a laser gun, virtual laser gun, that when you activate a certain pixel, we calculate the angle your eyeball is looking at the pixel, and from there we simulate the laser gun pointing from that pixel into this virtual 3D model. So we know exactly which 3D model looking at. You will see that from the playback. So this is not playback, it's just a person, my student was looking at like reviewing the 3D model. And later we will show you the playback of that, like where he look at in the 3D model. You see that lines of going on over there? It's actually plotting 3D lines in the 3D model based on which pixel we were activating and how it shoot into the 3D model. We're actually developing a lot of technologies could be potentially patent. Okay, so this is just some results. As you can see, we give people different, the test subjects different different tasks, like give you this isometric drawing with textual information. We want to see like which area, which information you're paying attention to. And also this one shows the pupillary change, the Unfortunately, we didn't change the unit of measure. Here is meter, okay? But this is a 3 millimeter, 3.5 millimeter, 4 millimeter, and this is a frames. You can see the sudden drops. Those are blinks, like you will blink your eyeballs, okay? Blink your eyes. And those up and down shows the pupillary change after we're removing the light response. And this one shows the trajectory of your gaze focus in the 3D space. So you're plotting a map using your eyes in the 3D space. Let me show you a very interesting video, like how this pupillary analysis can be useful. It's actually, if you're interested, you can go to our lab webpage. We have some interesting video there. And this video shows that how this simple method can be used to check if a person is thinking too much. This video shows a real-time can you guys hear the sound of this video? Okay. Cognitive load tracking system using the pupillary size of a person. As you can see, the upper one shows the real-time pupillary size, and the lower one shows the luminance, which is how bright the environment is. We calculate the RGB value of each pixel inside this VR goggle and convert that into the luminance. And we have a formula to remove the light response effects. So the residual shows the pupil size change driven by the cognitive load. As you can see, when this person moving around, the luminance is changing, the pupil size is also changing accordingly. All right, now we just ask this person to stare at the same place. And as you will see in a moment, the luminance start to stabilize. Now we ask this person a very tricky question, 133 times 55. Now we can see the luminance stays the same, but this person's pupillary size just increased dramatically, around 20%, and start to stabilize. Yeah, so actually I had an interesting experience. Early this year, we were invited to attend the CES show. I don't know if I have it here. So to demonstrate, the technology that we developed. Yeah, over there. Yeah, that's a CES show. You guys know CES show, right? Consumer electronic show is the world largest consumer electronic show. Like everybody, you hear Apple, Google, Samsung, they were there showing their latest technology. So anyway, we were showing this VR goggle based way to tell if a person is nervous and all their cognitive load. So a police officer actually visited our booth, and so I was doing the show. Okay, so then I asked my students to ask me questions and say, Professor Du, can you do the multiplication? 33 times 33. The thing is, the more I think, I need to think this form question to show my load is increasing. The more I think that, the less I can think the mathematical question. You got the point? Because I'm so eager to show the system is working. My mind is not thinking the mathematical function, the problem at all. So they basically see the lines leveled. Then the police officer asked me a question. Hey, Eric, have you ever violated the speed limit but didn't receive a ticket from us? Then they start to see the lines just hiked, and they say, wow, your system does work. So just it shows that sometimes you cannot have what we call physiological sensors signals. Okay, so this one shows the image we received from this neuroimaging device, the infrared light, and the red color shows more oxygen consumption. Blue color shows more less oxygen consumption, and you guys see this color is changing regularly, right? Can anyone tell me what that is? Why it's doing this? Anybody just think about that? I'm talking about oxygen. That's your heartbeat, because your heart is beating. So yeah, we have to do some mathematical analysis to remove your heartbeat from once again the data. We're talking about data analytics. It's all about how to find the noise, how to remove the noise, how to filter out data, smooth data. Anyway, so this one shows the time. Here is time, and the Y shows 18 channels or 18 bring areas, and the color change shows the oxygen change. So we did this experiment. We gave them this task, maintenance task to do. They have to rotate the valve, turn on, turn off the valve in the right sequence. We give them the 2D drawings, 3D model and the VR model to train them, and we ask them to do it. And this is how it looks like, how people were doing their task.
All right. So
Okay, that's took really long. Okay, so first we compare task performance. That's probably something we are immediately interested in. In terms of the accuracy of their operation and also time. The more accuracy we achieve, that means better performance, and the less time means better performance. So this 2D to the complex. 2D complex means we provide also a lot of textual information like guidance. 3D and VR, and yes, we did see 3D and VR did improve their performance, and like in terms of accuracy and reduce time. So yeah, 3D and VR for this group of people, actually 120 people, that's a really good sample size. Yes, it improved. Then we check their cognitive load. This is actually their cognitive load based on their pupillary dilation, and we have data also shows their brain functions. Here is a very interesting we discovered. 3D and VR, they actually generate or lead to higher cognitive load. Okay, now I'm going to stop here for a moment and ask you guys, remember we had some argument in the literature that somebody said 3D and VR will benefit the construction in the future because they provide additional information. From this figure, we show, yes, they prefer the performance. But some people also argue that because 3D and VR provide additional information, that will burden your cognitive load. Yes, but how come they come together? That's my question for you guys. If your load is increased, how come your performance will be better? Anybody? Can anybody tell me? Think about that. And by the way, guys, this is research. A research becomes exciting because it becomes interesting when we see this. When we see some conflicting things going on, when we don't have an immediate answer, when we feel so difficult to explain what we are seeing, that's when I got excited. And you will see it's no difference. What I'm working on here is something called fulfillment factors. You probably think my research is more related to psychology. Yes, but the research with civil engineering, with structural, with coastal engineering, same thing. When you see different things, conflicted things, when you don't have an answer, that's why we fall in love with research. So now I'm asking this question: what is your hypothesis? Why 3D VR increase your load, make you feel more difficult, but your performance is better? Anybody? Come on, guys. Junyi, are you there?
Yes.
What's your hypothesis? Just think.
Difficulty promotes us doing better.
Sorry, what's that? Difficulty promotes what?
Promotes us doing better.
Oh, that's actually a good angle, right, guys? So basically what Junyi says is that something more difficult doesn't mean that we have worse performance. Maybe it's because it's difficult that we tend to have better performance because we are more focused, correct? Anything else? Okay, let me show you what we discovered. We found a limitation or barriers of a lot of previous study is they only measure the cognitive load when you are seeing the information. So when you're looking at a 3D model, when you're looking at a VR model, when you're looking at a 2D drawing, and measure your cognitive load. But they have never measured when they are using that information. You got my point? So let's say you are a construction worker, I give you this drawing instruction, and then you go to work. They measure when you are reading the drawing, how difficult it is, but they never measure when you are working and when you are trying to retrieve the memory from your brain, what happened. That's what we did. That's the angle we are tackling. This is the cognitive load when they are performing the task. What happened here? 3D and VR shows what? A lower cognitive load. Now you guys can understand what's going on here. You know, we also have some survey. We ask them, did you feel more difficult of using VR and 3D? They answer no. But the data shows yes. What happened? Because your experience is a holistic experience. Let me show you this. You are reading the information, which we call information encoding, and it becomes your memory, working memory, storage. And when you're using that, you're retrieving that memory. Holistic speaking, your experience is based on the load when you're encoding the information and the load when you're recalling the information. And it's more affected by the load of when you're recalling information. So we have this idea called a conversion ratio, like the load for recalling the information divided by the load for encoding information. Guess what I found? 3D and VR gave you very low or very efficient conversion, which means that it's easier for you to recall the information. So using English, what happened here? When you are using 3D and VR to do something, to learn something, it is difficult, that's for sure. But it will become so easy for you to use the information. Why? Imagine that I gave you a 3D model to memorize the location of a column. It should be more difficult than just looking at a 2D drawing to see the location. But when I go to the job site, everything sounds so familiar because I learned it in the 3D world. I work in the same 3D world. This is called a state-dependent learning. The most efficient way for you to use my brain is I learn it in the same environment. You learn how to swim, you have to swim. You learn how to drive, you have to drive. That's how your brain adapts to the task, not just reading the information. Make sense? And we go deeper into that, we found an even more interesting thing. If you add the load for using the 2D drawing, reviewing the 2D drawing, and using the 2D drawing information, you add a 2D complex, 2D complex 3D and 3D, we found the total cognitive load for you to review the information and use the information remain the same. It just 3D and VR models help you move the cognitive load to the front end. So which we call this cognitive load, cognitive budgeting theory. So you have the same budget. It's just when you use the budget. The traditional 2D drawing, traditional way, you tend to use less load when you're reviewing the information, but you have to use more load when you're doing the work. And the 3D and VR, the newer information technology, will make you feel more difficult when you review the information, but it's much easier when you use it. Now, question, which method, which scenario is better for our work? Having load at the front end or having load when you're working?
In the beginning, of course.
Front end, right?
Yeah.
It's kind of like we are leaving all the difficulty things at the beginning, right? Yeah, that's the benefit of VR and 3D. So now let's go back to the literature. And I spent some time talking about this because I really want you to feel the beauty of research here. Now think about for the earliest publication is 1999, so it's 21 years ago, and also some recent publications in 2014, 16, 4-5 years ago. People make their observation, they tend to give their explanation, but for the first time, we try to give a framework that can consolidate all the findings. Okay, and we give a very different explanation, and all of a sudden we explain why for both of the groups. So that's how we feel so happy, and so the feeling of accomplishment. And of course, we are working on some newer projects like this one. The more we look into this area, the more we found we don't know yet. So what we found actually, our brain has, like I mentioned earlier, our brain has different areas, right? And we found, given the formats of information, phonological information, this is something related to symbols and language, visual spatial information related to colors, spatial configuration. Actually, that will be processed by different areas of your brain, represent very different cognitive functions and processes. And also we have certain areas, central executive, related to the, like I said, PFC. It's kind of like a boss that's guiding different areas of the brain how you should allocate the information processing. So the true picture is even more complex. The information we are giving to you, 3D model, VR model, it contains different kinds of information. Something about the color, something about the texture. That, if you go deeper, that can also affect how you perceive the difficulty of the task and how safely and effectively you can use the information in your real world operation. Okay, so this is a quick overview of VR and AR, and the second part, I go deeper, into our current ongoing research. So I want to take about several minutes with you guys, maybe 10 minutes, to have some discussion with you guys. What do you think about this VR AR, given what Rami showed in the literature review and also what I showed today? What would you project the future of VR AR in the AEC industry? Anybody? If not, I'm going to call names, okay? So Rami, maybe you're the first since you shared your paper.
I guess like using virtual reality would like improve the design process significantly. Improving the design by using the virtual reality would be like useful in the future.
So in the design.
Yeah.
So here's a question. So I was talking to a lot of design companies, and a lot of VR users, they have the wow moment. It's the first time VR user, when they put the VR goggle on, they always say wow. But then after a while, they say, I think this is a great technology, but it's too early to use in our business. What do you think what their concerns are?
I guess the concern is maybe just the cost at the beginning, because it's a new technology and like this. I guess it's like very helpful in the design process.
Okay, so my explanation is twofold. One thing is the data standard. For example, in Revit, in AutoCAD, if you want to build something, you can easily find the libraries. You can find the standards, but we just haven't moved everything into VR. Like, if I want to install a particular kind of a door, I don't have that in my database, in VR. So it's probably too difficult, but it's easier for me to do it in Revit, right? The second thing is human-computer interaction. Like I said earlier, because we are so used to the traditional way of designing things, like use a piece of paper or use AutoCAD to draw the lines and the curves. But now you ask me to move my body and use the controller to do something or pick up something. That's probably too new of an experience to me. And maybe it's difficult for people to adapt to that new experience, right? So I want to show you guys a quick video. It's the Google 3D brush. Now you see how people use VR do design. It's fashion design, not the building design per se, but people imagine that should be the next generation design for building industry as well. So let me show you that video quickly. You guys can hear the sound, right? So actually, I used to play this tube brush, Google Brush, like for hours, and I really enjoy building a real scale structure with this thing. But like I said, that represents totally different, HCI, user experience. That's probably why, right? Anybody else? Like, what's your thoughts about the future of VR AR technology in AEC? Rohit, are you there? Okay. Abraham, are you there?
Yes, I'm here.
Yeah, can you share some thoughts?
Okay. I guess one of the uses of the RV in the construction in the future is not just in the design phase, but also during the construction. So the project manager or the supervisor or the site managers, they can evaluate the workers' progress in the work, so they can see if they are doing the work right or not. And they can use the virtual reality to see how is the final design comparing with the reality or the current design. And I think we saw one of the uses when we had the guest lecture in, I think, Synchro Pro program. When we had the Synchro Pro, oh, that in the another lecture, not here. Yeah, so I get confused. But yeah, I saw that and I like it actually. They even can figure out the pipes under the ground, so they can just see them by using the virtual reality, which is very interesting actually.
Yeah, let me show you exactly. I agree with you what you said. Let me show you. Timberline actually has a lot of work with not Trimble. Sorry, Trimble has a lot of work with AR. Shoot, there's a mosquito. For construction support. So let me just go into open. Trying to find a good video for that. Okay. No. Okay, let me share the screen.
Wow. You can zoom in.
That's the wow
and go
moment.
out. That's so cool. Like that?
Yeah.
Just.
You can walk.
It's right there on the column. I can see it on the column. But they said you should use your hands kind of like a control, like a mouse, to be able to click on it. Move, pinch hand, and pivot alignment.
Just slide this on and use it almost like a welding hood, but just for quality control check, for layout. I mean, I'm constantly measuring with the model on my iPad. Coordination would be the main phase that would help for us.
This is exactly what I'm seeing in the office, but you can actually get real life, which is great for a lot of remodels, especially hospitals. Because a lot of times there we can't even see what's already been built. So being able to walk through with what we do versus what they already have would be great. Well, obviously on the blueprint you don't have 3D, so you can't see layers on it. You can only see like an overhead looking down, and there's usually a lot of lines running above or below each other, which you know the general area where it's supposed to be, but you don't have an idea of elevation. The best one I can see is definitely for remodels where we don't know what's already there. So then we could use this to really get an idea of how we need to coordinate around what's already there.
So we got a duct squeezing between those two conduit racks right there.
That's awesome.
Very cool.
So if you're interested in VR and AR and maybe potentially become a developer of that, this game engine called Unity. I don't know if I can find a quick video to show how it looks like. So basically you just create a 3D models in this Unity and maybe I can find a quick tutorial. Yeah, the tutorials are probably always too long, but as you can see, it's very similar to like a learning Revit, right? So basically just build a 3D objects in Unity, define the properties of that, define the behaviors of that, add a camera, and then now it's very easy. You just have export to VR. So Unity supports you to export your model into the mainstream VR and the AR system. You design the model and then all of a sudden you have all the applications available.
I would say mostly just real-time life.
So this is basically, if you're interested in that. Okay, last comment from me. So we found, based on the our latest research, we found AR is very different than VR in terms of cognitive load and performance improvement. The thing is, the use of VR always involve the work memory development. So you have to digest the information first, stay in your brain and use it. But AR is more on the fly. So you just use the AR and you see the things and you start to process information very quickly. And we found AR is more efficient than VR in terms of digesting and using complex information, because you do not need to find a place in your brain to store the information temporarily. And from a human factors perspective, that's probably why AR is more welcomed by construction workers, by construction companies. We start to see that coming very fast. Okay, guys, any question, any comments in terms of VR, AR? If no, let's take a 10-minute break and we will come back at 6:35. All right, see you guys then.